Hello everyone, this is Teacher Michelle and welcome to another episode of Unang Math. For this episode, I will be covering this lesson about the characteristics of the graph of this linear function y is equal to ax plus b. Okay, this function y is equal to ax plus b is from the function y is equal to ax. We already had a separate video lesson about this topic, and that is on episode 129, entitled Direct Proportion Equation. Take note, a direct proportion equation is also a function. So, y is equal to ax is also a function. Okay, in this episode, I will be discussing the important characteristics of the graph of this linear function. Okay, let's start with the first characteristic. The sign of A determines the slope's direction. Okay, in this linear function, y is equal to ax plus b, the sign of A, which means it can be positive or negative. The sign of A determines the slope's direction. We all know that a graph of a linear function is a straight line. The value of B or our y-intercept doesn't determine or doesn't tell us the slope's direction. So from that, we are going to consider only this function. Okay, let's give a specific function. We have here y is equal to 2x. Okay, let's graph this function. In order to graph this function, we need at least 2 points. And we already know that this function's graph passes through the origin. So our first point's coordinates are 0, 0. Okay, we need one more point. Okay, let's say x is 1. So it means 2 times 1, then y coordinate is 2. So our next point would be, so 1, 2. So this point. And if we are going to connect these 2 points, then the graph looks like this. It slopes upward. Okay, what about if our function is y is equal to negative 2x? So, a is a negative number. Okay, we already know also that this function passes through the origin. So, our first point is at the origin. Okay, what about the second point? If x is 1, then y is negative 2. So, if x is 1, y is negative 2, that means this point. And if we're going to graph or connect the 2 points, then the graph looks like this. It slopes downward. Okay, as you can see, if the value of A is more than 0 or a positive number, okay, y increases from 0 to 2. So from 0 to 2, and x also increases from 0 to 1. Okay, how about if the value of A is less than 0 or a negative number? Okay, y decreases as x increases. Look at the value of y from 0 to negative 2, so it decreases. What about x? From 0, we have here 1, so it increases. So that's the first characteristic of the graph of this function y is equal to ax plus b. Okay, moving on to the second characteristic. According to this one, the larger the absolute value of A, the steeper the graph, which means it would be closer to the y-axis. Okay, as a brief recall, absolute value means any number, whether positive or negative, absolute value is always positive. So in the second characteristic, if the absolute value of A is larger, then that means the graph is steeper or it's closer to the y-axis. Okay, let's give an example. Let's graph this linear function y is equal to negative 2x, and this function y is equal to negative 4x. Okay, we know that the graph of these functions passes through the origin. Okay, so if we will graph y is equal to negative 2x, our first point passes through the origin or at the origin, and let's get another point. So if x is 1, then our y is negative 2. So the another point is this point. And if we are going to graph, then the graph looks like this. So this is y is equal to negative 2x. Okay, what about y is equal to negative 4x? Okay, the graph also passes through the origin. Let's get another point. If x is 1, then our y is negative 4. So 1, 2, 1, and then y is negative 4. So another point is here. And if we are going to graph, then the graph looks like this. So this is the graph of y is equal to negative 4x. Okay, so you can see in these graphs, the larger the absolute value of A, it's steeper or it's closer to the y-axis. So the graph of y is equal to negative 4x is closer to our y-axis. It's because the absolute value of negative 4 is larger or bigger than the absolute value of negative 2. Okay, moving on to the third characteristic. According to this one, the sign of B determines the location where the graph crosses the y-axis. So in this function, y is equal to ax plus b. Okay, the value of b here is also called our y-intercept. So according to this one, the sign of B, which means can be positive or negative, it will determine the location where the graph crosses the y-axis. Okay, let's give specific example. We have here y is equal to negative 2x plus 2. So y-intercept or the value of y is a positive number. So if we are going to find this point, it would be this point. So if b is more than 0 or a positive number, then the graph crosses the y-axis at a positive value. So the graph crosses this y-axis at a positive value. So if we are going to draw the graph of y is equal to negative 2x, since this is negative, then we can expect that the graph slopes downward. Okay, what about if b is less than 0 or if b is a negative number? Okay, let's say y is equal to negative 2x minus 2. So if b is less than 0, the graph crosses the y-axis at a negative value. So our y-intercept is negative 2. So it means this point. And if we will graph this function, then the graph looks like this. So it crosses the y-axis at a negative value. Okay, this time, for another examples, let's answer this concept check question. For the graph of y is equal to negative 2x plus 4, we are going to write 0 for true and x for false in the parentheses. Okay, let's start with the first sentence or in the first number here. It is a line that goes upward to the right. Okay, check this function. Y is equal to negative 2x plus 4. If the graph of this function goes upward, then that means the value of A should be positive, but this is negative. So number 1 is false. What about number 2? It passes through the origin. If the graph passes through the origin, then the function must be y is equal to ax. We have here plus 4, or we have here the value of b. So it means this is also false. In number 3, it intersects the y-axis in the positive region. To know whether the graph intersects the y-axis in the positive region, we have to check the value of b. If it's positive, then it intersects the y-axis in the positive region. This is positive 4, so that means number 3 is true. And for number 4, it is closer to the y-axis than the graph of y is equal to 4x plus 4. To know whether the graph is closer to the y-axis or steeper, we have to check, we have to check the absolute value of the value of a. So, y is equal to 4x plus 4. Absolute value of 4 is 4. But in this function, y is equal to negative 2x plus 4. Absolute value of negative 2 is positive 2. The larger the absolute value, then that means it's closer to the y-axis. So, is it closer to the y-axis than the graph of y is equal to 4x plus 4? Then this means this sentence is false. Okay, for this simple activity, let's answer this one. Choose all the graphs of linear functions in the box below that match the following descriptions. So we have here two descriptions. We're going to choose which among these functions match this description. Okay, the first description is a line that slopes downward to the right. Okay, to know whether the line or the graph slopes downward to the right, we have to check the value of A. It must be a negative value. So in these options, we have here negative 3 over 2 and negative 4. So it means a line that slopes downward to the right, we have line A and line D. Okay, what about number 2? A line that intersects the y-axis in the negative region. To know whether the line intersects the y-axis in the negative region, we have to check the value of b, or our y-intercept. If the line intersects the y-axis in the negative region, value of b must be, or the sign of b must be negative. So we have here this, negative 6, and negative 1. This is positive. This is also positive. So we have A, okay, and line C.